Okay. Okay. At the end of the previous part, I have described about the VOC. VOC, eh? So the term OC is actually refer to the open circuit or unloaded voltage. So again, I write here, OC is open circuit. Circuit. So here you see this the output port. There is no RL connected. So the V out, although we have the Z out here, so the V out will should be equal to AVOC V in. So because the current is 0 and here the voltage is 0. So no voltage drop, so the output will be equal to the what produced by this AC source. Okay, here V out is equal to AVOC V in. And then if the resistance here, the internal resistance is 0, so the V in is equal to Vs. Okay, this is unloaded voltage gain. Okay, we have the loading effect at the input. So the loading effect uh, occurs due to the internal resistance of the source. So the amplifier input voltage V in will be less than Vs because the voltage division between Rs and Zi. So this is we have derived this one as the V in. Again, make sure that you can differentiate between Vi and Vs. Vs is the one that the parameters, the supply voltage, and then the V in is the actual voltage value being inserted or being applied uh, to the amplifier. Okay, so this is V in, and then you know V out. V out is equal to AVOC V in because there is no voltage drop at Z out. So, and then V in, by using this the first equation, you can get this Zi over Rs plus Zi Vs. So lastly, you can define gain denote as a AVS. So AVS, what is AVS? Is a V out with respect to the signal voltage Vs. So you can get AVOC times Zi over Rs plus Zi. So the gain of the amplifier will depend on your definition. So whether you define the gain, so we have many definition of the gain. Let's say if the gain is AV is equal to V out over V in, or it can be V out over Vs. So it's many possible for the gain. So make sure you know what is the definition of the gain that you want to analyze before you do the analysis. At the output part, if you connect with the RL, so the V out will be, you can use the voltage divider and you can get the V out. This is we have done the derivation in the previous part. And then we know the AV is V out over V in. Okay, here AV is V out over V in. So the AV is defined by this equation. If the AV is V out over Vs, you can get this equation. Okay, so you see this the total gain here AVS will consider the voltage drop at the output and voltage drop at the input. Okay, if you have the voltage amplifier model and you want to calculate or analyze the current gain. Okay, so the current gain, you can analyze the current gain using a very simple circuit analysis method. So I out is AVOC V in over Z out plus RL. So this is a Ohm's law or KVL. Okay. KVL along this loop. So we can get I out is equal to AVOC V in over Z out plus RL. So and then the V in, what is the V in? V in is I in times Z in. So this is Ohm's law. So now you get the I out as a function of I in. So because here the first equation as a function of V in, and then next we define the V in as a function of I in, and then lastly, if you combine the first and the second equation, you can get I out as a function of I in. So I out as a function of I in, you can analyze the current gain, which is, let's say this is I out over I in. Okay, this is the current gain. And then next, the input current is the current at the input port. So this is slightly lower than the actual current source current. So using the current divider, I in is equal to Rs over Rs plus Zi. So lastly, you can get AIS. So AIS, consider this is at the input part, and then this is at the output. Okay, this slide summarize all the relevant equation. So my suggestion, no need to memorize all of this equation. As long as you can do the analysis using the voltage divider. So the important is voltage divider and then current divider equation. Okay, so these are two important equation that you need to master and be able to use. And then beside of the equation, make sure you know what is V in, what is the difference between V in and Vs, and what is I in, what is I out, what is Is. So this is also important.